Let's take a look at the last section of chapter 10, 10.6, binomial distribution. And in this section, we're looking at it's the last of our probability. And so let's get started right here and take a look at some vocab. The first thing we're going to look at is this term of random variable. And random variable right here, it's a variable whose value is determined by the outcomes of a probability experiment. So we're going to take a look at, hey, what are some, if we're thinking about flipping a coin, the outcome of it being heads or the outcome of it being tails, that would be, it's completely random when we think about the probability there. For our next term, we have probability distribution. And that is a function that gives the probability of each possible value of a random variable. And then the sum of all probabilities must equal 1. So when we think about the chance of success, the chance of failure of flipping a coin, it's 50-50. But when we think about the sum of all the probabilities, it's going to equal 1, right? Either you're going to, when you take 1/2 and you add 1/2 or 50% and add 50% of a flipping a heads or tails, it would end up equaling 1. For our third term right here, we have binomial distribution. And this shows the probabilities of the outcomes of a binomial experiment. And binomial distribution I have right here in parentheses is a type of probability distribution. And so what is a binomial experiment? We'll get to that coming up pretty quickly. It'll be in our core concepts. It'll be the second one that we look at. So let's take a look right here at our probability distribution. So once again, a probability distribution is a function that gives the probability of each possible value of a random variable. And then once again, I think the key thing was that the sum of the probabilities of distribution of all the probabilities in a probability distribution must equal 1. When you take a look at this table, and this is about the probability of rolling a 6-sided die. And so in a 6-sided die, you have a 1 in 6 chance of rolling a particular number, 1 through 6, right? Because there's 6 sides, and so the probability of rolling or tossing a 1, it's 1 out of 6. So you could see right here, kind of reiterating, all right, the probability of tossing a 1, 1/6. Tossing a 2 is 1/6, 1/6, 1/6. All right, all the way till probability of rolling a 6. You have a 1 in 6 chance. And so when you add it all up, that ends up equaling 1. Next up, let's take a look at our binomial experiment. Okay, so what is a binomial experiment? It has 3 of these following conditions. Okay, and so these conditions are all important. You have to have all of them. The first one is that there are n independent trials. Okay, so you're going to have particular outcomes trials, whether you have rolling a dice 6 times, flipping a coin 10 times, those would be independent trials. One doesn't have any bearing on the next. The second criteria is that each trial has only 2 possible outcomes, success or failure. So in the instance of flipping a coin, that would be a binomial experiment. You're either going to flip a heads or you're going to flip tails. If you want it to be heads, then that would be the success. Flipping the tails would be the failure. And then the third one is that the probability of success is the same for each trial. This probability is denoted by P. The probability of failure is 1 minus P. Okay, so when you flip a coin, you're always going to have either heads or tails, right? So the probability of success is going to be the same each and every time. Right here at the below it, it says for a binomial experiment, the probability of exactly k successes. All right, so we have this variable k, that'll be the number of successes in n trials, is going to be noted in this equation that I would make sure that you know and memorize for the test. Okay, so once again, make sure you memorize this one right here. And so what it's saying is that the probability of whatever it might be, let's say we flip a heads, okay? How many times can we flip a heads? And then what you're going to do is you have the success and then the number of times you're going to flip. That will be n in the trial or in our experiment. And so then you would plug all of that here into our equation using a combination. Okay, so you got to use your calculator and combination, and then you would be able to come up with the successes. Okay, so let's begin to put it all together right here and take a look at this first problem. Okay, so it says, let's make a table and draw a histogram showing the probability distribution for a random variable of p if p is equal to the product of when two-sided die are rolled. Okay, so I've got this big old table right here, and it's going to be big because first off, it's asking for what is the probability when two-sided die are rolled. Okay, so what I'm going to start right here, I've got 19 columns, 3 rows. And so this first row right here, what I'm going to go ahead and put is we're going to talk about the probability of each product. Okay, so I'm going to go ahead and put P, and then that is the little bar, and product. So this is supposed to represent right here the probability of the product. Now, the thing right here is, why do I have so many rows? It's because of the fact that there are going to be a lot of different outcomes, right? What are products? So we have to start off and first think, well, what are the different products when we flip a two-sided die? So let's say on one dice you have a 1, on the other dice you roll a 1. So 1 times 1 would be 1, right? So I want to go ahead and go through all of them, right? So the first one would be 1. And let's think, if you roll a dice, you have a 1, and then the second one you have a 2, right? And then we roll a 1 and a 3. So that's 1 times 3, 3. Rolling a 1 and a 4. That gets us 4, 1 times 5, and 1 times 6, right? So that gets us through at least the first few right there. And then as we continue on, you have to think, well, what more can we have? All right. Well, what if I roll a 2 on one of the dice and then I roll a 2 on the second dice? Well, that gets me 4, but then that's overlapping, right? So I'm not going to do that again. And so we're going to kind of go through the list, right? If I go through like 2 times 3, that's 6, but I already have a 6. 2 times 4, that's an 8. That's a new number, right? So we're going to have 8. And then we have 2 times 5. All right, that gets us 10. But before we kind of skip around with numbers, let's try to figure out, well, what are all the different numbers that we can have that we haven't already chosen? All right, I can roll a 3 and a 3. That'll get me 9, right? 9, 3 times 3 is 9. And then let's go ahead. We got 2 times 5. That'll get us a 10. We have 2 times 6. That's 12. Okay, so what you see now are all of the different factor possibilities. So I'm going to go ahead and just put them all down. Hopefully now you understand how I'm getting these numbers. Okay, so these are all like different factor combinations with the two dice. Like 36, it'll be if I roll a 6 and a 6. The next thing I'm going to, in the second row, what I'm going to start, what this is going to be about is the outcomes. Okay. So how many outcomes can we have of rolling a 1? Okay, so if I roll a 1 and a 1, that's one particular outcome for me to get a 1. Okay, so there's only one way for us to get that, and I'll go ahead and put a 1 right here. Right, how many ways can I get a 2? Right, I could roll a 1 and a 2, I could roll a 2 first time and a 1 the second time, right? So there's actually two outcomes for us to get a 2. So I'm going to go through this and figure out, well, how many different ways can I roll a 3? I could roll a 1 and a 3. I could also roll a 3 and then a 1, right? So those are two different ways for us to get a 3. How about a 4? What are some different ways? I can have a 1 and a 4. I could have a 4 and a 1. I could also have 2 times 2, right? And either way, 2 times 2 is going to be the same thing. So that gives us a total of 3 outcomes right here. So I would try going through and see if you could figure out all the different outcomes in the problem. I'll go ahead and work through them right now, but I would think that it would be helpful if you maybe paused it and then you went and try to figure out all of the different possible outcomes for each one. So once again, I'll go ahead and put these down right here, since I already did it, and then to kind of save time on the lecture. But once again, you can go ahead, I would think, take a moment, pause, and see, well, how many different can you find all the outcomes that I have put down right here. Okay, so we have this now. How many total outcomes are there? So that's what's important right here. And if we take the sum of all of these, it equals 36. Okay, so we're going to need this number right here. We have 36 right here, total outcomes in getting these different numbers or products. So now, for the last part, I'm going to go ahead and put, well, what is the product or the probability of getting a particular product? Okay. So what is the probability of us rolling 2 1s right here and getting a 1? And so that right there, we want to create a probability, we get ourselves a ratio. And that's why we talked about the total number of outcomes, or figured that out. So this right here will be 1. You got 1 out of 36. Okay. For 2, it'll be 2 out of 36, which simplifies down to 1/18. And so let's go ahead. We'll continue it on. With 4, it's 3 over 36. So that becomes 1/12. And let me go ahead and fill in the blanks now. Try to get through this quickly. For 12, it's 1/9. And remember, that's taking 4 over 36 right there and simplifying it down to 1/9. We've got 1/18, 1 over 36, 1/18, 1/18, 1/18, 1 over 36, 1/18, and 1 over 36. So if we take all of these probabilities and outcomes, if you turn them into decimals, or even if you add up all the fractions, everything right here will end up equaling our number 1. Okay. The last thing would be to draw a histogram, and when you draw a histogram, you could think of it as a bar chart. Okay, so I'll just kind of real quickly, if we were to think about down here, we would have the outcome or product for X, and then we have the probability for Y. Okay, and so like the different products, we have 1, 2, 3, etc. And then we'd go ahead and put like 136 is 0.027. We have 0.05. So we can go ahead and put like 0.02, 0.05, 0.07, etc. And then you go ahead and make your bar chart or your histogram, and that would be it. Okay, so that right there is a histogram in case you forgot what it is. Let's go ahead next, take a look at number 2. Let's move it along right here. And so you have your histogram right here. And it says use the probability distribution to determine A, the number that is most likely to be spun on a spinner. And then B is the probability of spinning a perfect square. So first off, all right, what is the probability of, or the number most likely to be spun on the spinner? And if I take a look at the diagram right here, it would be 4, right? That is the highest one, right? So it would be the number 4. Part B, what is the probability of spinning a perfect square? So what are our perfect squares? Hopefully we realize, if you can take the square root of a number and come up with a nice whole number, then that ends up being a perfect square. So right here, one of them would be 4. Okay, so we got the probability of rolling a 4 because that's one of our perfect square. The probability of 1. All right, so let's go ahead. We'll add those 2 up. And so if I look at the diagram right here, the probability of 4 is 0.4. The probability of 1 is 0.2. So if we put it all together right here, that ends up getting us 0.6. And that is the probability of spinning a perfect square based on the experiment that is shown in this spinner results. Okay, just that simple. Next up, let's take a look at number 3. It says calculate the probability of flipping a coin 20 times and getting 19 heads. So this is where we're going to be using our binomial experiment. Okay, how do I know to use the binomial experiment? Well, we're trying to find the probability of flipping a coin. There's 2 outcomes, heads, tails. Remember, what I care about here is, in the binomial experiment, is finding the probability of the successes. So right here, the success would end up being 19 heads. So let's go back to our equation that we have. The probability of k success, and that's equal to n c k, k being the success, p to the k power, and then we have 1 minus p to the n minus k power. Okay, so this right here will help us to find the probability of flipping a coin. So let's start off. What do we care about? Okay, first off, we need to know what n is, and n is the number of times we're doing this in the experiment, and that would be represented by 20 times. All right, so I'm going to go ahead right here for n. We plug in 20. We have a combination, and for k right here, what I care about is my number of successes, and my success, what I'm looking for very specifically this time, is 19. All right, so we have 20 combination 19. Then let's go ahead and take a look at for p. Well, what exactly are we looking at? The probability of flipping a head. So that right there would represent p. That probability is going to be 50%. Right? You have a 1 in 2 chance of flipping a head. And so in this instance, we have 0.5. We need to raise that to the k power, which happens to be the number of successes, right? So the success rate right here that we want is 19. That's, that's hard. If you flip a coin 20 times and you want 19 of them to be heads, if I was a gambling person, I would not take that bet. So then the second part is this 1 minus p. Well, the 1 minus p is going to represent the other side of it, right? It is going to represent the probability of failure. Well, luckily right here, the probability of failure is 1 minus 0.5 because, well, you have a 50-50 chance. So right here, we take 1 minus 0.5 and we end up with 0.5. And then for the top, for our exponent, it's n minus k. Well, there's n is 20 times for the experiment, and then minus 1, because that is the number right there for, or sorry, 20 minus 19, because we want the number of success, and that'll get us to the first power. All right, so what you need to do is carefully plug that into your calculator and then see what you get. So over here on Desmos, let me go ahead right here. We're dealing with combination, so I'll press the combination button. We have 20, and then let's go ahead, comma 19. Okay, so that's the first part. Let's close it up. All right, and then from there, we need to take that answer. We're going to multiply it by, we'll take 0.5. Let's raise that to the 19th power. And then let's take the probability of our failure, which is 50% or 0.5, and then we will raise that to the first power. We don't really need to, but hey, that's part of the problem right here. And I'll just go ahead and plug it in. And let's see what we get. I get 1.0973 times 10 to the negative fifth power. So let's go ahead. Let's plug that in right here. I end up with 1.9073 times 10 to the negative fifth power. And so if we go ahead and put that into a number that maybe we're a little bit more familiar with, it'll end up being, we'll move that decimal point to the left, and this will become 0.000019. Okay? And so if you see this number right here, that's not even close to 1. It's like way less than 1. You don't even have a 1% chance, hardly, of flipping 19 heads in a row. You could try it out yourself, but hopefully you realize, remember, each and every time it's random. Each and every time you flip a coin, you only have a 50% chance of success. And so the chances of that happening are not very high. Let's go ahead and take a look at number 4. All right, there's 3 parts to this. It says first draw a histogram of the binomial distribution of your survey. So before we can do that, we've got to figure out, well, what are some probabilities of successes and failures here? And it says, according to the survey, 78% of women in the city watch professional football. You ask 4 randomly chosen women from the city whether they watch professional football. Okay, so if we think about what's going on here, you have the chance of asking 4 ladies if they watch football. You can have all 4 watch it. You may have 3, 2, 1, or 0. Okay, so we have many different outcomes right here. And so let's go ahead and talk about, or try to figure out, find the probabilities of each. Now for this one, the success we could go ahead and say is the probability of watching football. Okay, I would go ahead, this would be success, which would be representing of K. So let's start from the very beginning. Okay, let's say we have our combination. We have 4 ladies, we got combination, and let's figure out, well, what if we have 0? Okay, what if we have 0 ladies that watch football? Okay, so this is the initial combination. And then from here, let's go ahead. We start off, well, what is the percent? We start off with the percent of success. That's 78%. That'll be represented by 0.78. And then let's go ahead. We'll raise that to the 0 power, because we're saying, hey, the 0 women are watching. Okay, and then we have the success of failure would end up being 1 minus 0.78, which ends up being 0.22. And then let's say 4 women, all 4 do not watch, and then there you go. We'll put 4 there. So if we go ahead and calculate this, you'll end up with approximately 0.0023. Okay, very small number, just like flipping the coin. Because it seems like 78% of the women watch professional football. More than likely, you have a good chance that they will watch. Let's go ahead and go to the next one. Let's say we have 4 women, right? But this time we have one chance of success. That what are the probability of one of those 4 women watching? We have 0.78. We raise that to the first power. 0.22. We raise that to the third power, right? If we have one lady watching, then that means there's one of the 4 isn't watching, so it's going to be 3. Go ahead and plug this in, we get 0.033%, right, or 0.033, which is approximately, if we're to, that ends up being what, 3%, say 3.3%. This 0.002 ends up becoming 0.23, or 0.23, so very small. Next up, let's go ahead, we'll try out of the 4, this time we have 2 watching. So we have 0.78 raised to the second power, 0.22 raised to the second power this time, and this will be approximately 0.176. So that's approximately 17% chance. Okay, let's go to the next one. The probability of 3 out of the 4 ladies watching. So we got 0.78 to the third, 0.22 to the first, and we'll go ahead and end up with this becomes 0.418, which is approximately 42%. Let's go ahead and put that there. And then finally with the last one, of all 4 ladies watching professional football, we'll have 0.78 to the fourth power, 0.22 to the 0 power. And so this right here, we'll get ourselves 0.37, which is approximately 37%. So if we have our histogram, since we didn't do it the first time, let's go ahead, I'll put it right here. We've got 0, we have the probability of getting a 1, 2, 3, or all 4. Right, so we go ahead, we got like 0.05, 0.1, 0.15, 0.2, 0.25, 0.3. We're going to run out of space. 0.3, 0.35. Well, we got like 4. So you get the picture. The probability of getting 0, it would be like kind of putting it like right around there, because there is that probability. Since it's so close, we can put 0.23 so that people would understand, hey, it's very low. The probability of getting a 1 ends up becoming 0.03. We'll put that right there. Probability of a 2, 1.7. Or 0.17. Probability of 3 is 0.418, so we'd have to go all the way up, 0.418. And then probability of getting all 4 watching is 0.37. So we'll have that. There's your histogram. All right, moving along. Try to finish things out as quickly as possible. We're almost there. So what is the most likely outcome of the survey? So if we look at all the probabilities and what we just came up with, hopefully we realize that right there looks like the most likely outcome. And so what does that mean? 3 out of 4 women watching or watch, we'll say, pro football. That is the most likely outcome here. And then lastly, what is the probability that at least one woman watches professional football? Remember, at least one. Okay, so it could be a combination of several different outcomes. It doesn't say that a woman has to watch 4. It says at least 1. So that right there, if we take a look at our original, we've got ourselves 0.3, or 0.033 because that's one lady. We also have there is a possibility right here that none watch, right? And then we can go ahead and put right here 0.0023. All right, so we put that all together, we end up with 0.353, which, I mean, either way we put it, we can go ahead, or sorry, the probability that at most 1. So anything from 0 and 1 would be a combination of that. And so this ends up becoming 0.035. All right, so the chance of that happening, not very high. All right. I'll go back and fix this. We have 0.0353. And there you go. If we were to go ahead and change that to a percentage, you have about 3.5% that at least one woman watches professional football. There you go. We have now finished chapter 10. Go ahead and please subscribe. Please like the video. If you have any comments, go ahead and put that in the comment section. And I will see you next time.